The first gun wasn't invented to kill people. It began as a failed search for eternal life. More than 1,000 years ago, Chinese alchemists mixed strange powders hoping to create an elixir of immortality. Instead, they accidentally discovered a substance that would transform warfare, topple kingdoms, reshape empires, and permanently change human history. What followed wasn't a single brilliant invention. It was centuries of trial and error, with each generation making one small improvement, until a simple tube filled with burning powder evolved into one of the most influential technologies ever created. The story begins in China during the Tang Dynasty, sometime in the 9th century. At the time, Taoist alchemists were obsessed with one goal: defeating death. They experimented with minerals, metals, herbs, and chemical mixtures, believing the right combination might extend life forever. Their laboratories looked nothing like modern science labs. They were filled with ceramic vessels, furnaces, scales, and handwritten recipes passed from master to student. One mixture combined sulfur, charcoal, and saltpeter, a naturally occurring mineral rich in potassium nitrate. Individually, these ingredients seemed unremarkable. Together, they behaved in a completely unexpected way. Ancient Chinese texts warn that this mixture produced violent flames and explosive heat. One account describes smoke so intense that it burned hands and faces while even setting buildings on fire. Instead of discovering immortality, the alchemist had stumbled upon the world's first known gunpowder. Think about how extraordinary that moment was. They had accidentally created a chemical reaction capable of releasing enormous amounts of energy almost instantly. Nobody yet imagined firearms, but humanity had just unlocked a force unlike anything it had controlled before. At first, gunpowder was treated more as a curiosity than a weapon. It appeared in fireworks and ceremonial displays, producing brilliant flashes, loud bangs, and thick clouds of smoke that fascinated spectators. Yet it didn't take long for military minds to recognize another possibility. If this powder could frighten crowds during celebrations, what might it do on a battlefield? The earliest gun wasn't really a gun at all. During the Song dynasty, beginning in the 10th and 11th centuries, Chinese engineers started attaching tubes filled with gunpowder to spears. These weapons became known today as fire lances. Initially, they projected long bursts of flame rather than solid projectiles, making them terrifying at close range during sieges and defensive battles. Imagine charging toward an enemy line, only to see soldiers suddenly unleash jets of fire several feet long. Even if the flames caused limited physical damage, the psychological effect was enormous. Horses panicked. Formations broke apart. Confusion spread almost instantly. Military inventors soon realized they could increase the weapon's effectiveness by placing small objects inside the tube. Pebbles, shards of pottery, metal fragments, and eventually specially made pellets were blasted outward by expanding gases created when the gunpowder ignited. That subtle change marked one of history's greatest technological turning points. The goal was no longer producing fire alone. It was launching a projectile using explosive force. By the 13th century, surviving Chinese illustrations and archaeological discoveries revealed true hand cannons made from bronze. These early firearms were short, heavy metal tubes with a small touch hole near the rear. A soldier poured gunpowder into the barrel, added a stone or metal ball, then ignited the charge with a burning fuse. They were slow to load, difficult to aim, often unreliable. But none of that mattered. For the first time in history, a handheld device could use controlled explosions to send a projectile toward an enemy. Every rifle, pistol, shotgun, and machine gun that would ever exist traces its ancestry back to these remarkably simple bronze tubes. And the technology was about to leave China, beginning a journey across continents that no emperor could ever control. The invention of gunpowder might have belonged to China, but its spread across the world was driven by one of history's greatest empires. In the 13th century, the Mongols expanded at a speed few civilizations had ever witnessed. Under Genghis Khan and his successors, they conquered territories stretching from East Asia deep into Europe. Wherever their armies traveled, they encountered new technologies, adopted useful ideas, and unintentionally carried them across enormous distances. Chinese engineers and craftsmen were often absorbed into Mongol armies after cities fell. Along with them came knowledge of gunpowder weapons, fire lances, explosive bombs, rockets, and primitive hand cannons gradually appeared farther west than ever before. This wasn't a single moment when one nation handed another the secret. It was a slow transfer through warfare, trade, diplomacy, and captured expertise. Muslim scholars and military engineers soon began studying gunpowder, refining its formulas and adapting weapons to their own needs. By the late 13th and early 14th centuries, knowledge of gunpowder had reached Europe. Written records from England, Italy, and Germany describe the mysterious explosive mixture, while illustrations begin showing crude cannon-like weapons capable of launching stone projectiles. What had started as an alchemist accident in China was becoming a global military revolution. Europe didn't invent guns, it reinvented them. The earliest European firearms looked crude by modern standards. Small hand cannons were little more than thick metal barrels mounted on wooden poles. A soldier loaded powder through the muzzle, placed a stone or iron ball on top, and touched a glowing match to the ignition hole. Every shot demanded patience. Rain could ruin the powder, a weak barrel could burst. Misfires were common enough that soldiers often carried traditional weapons alongside their firearms. Even so, commanders noticed something remarkable. Unlike bows, guns required far less training to become dangerous. Mastering the English longbow could take years of practice beginning in childhood. A firearm was difficult to use well, but a recruit could learn its basic operation in a fraction of that time. That changed the mathematics of warfare. Kings no longer depended entirely on generations of highly trained archers or elite crossbowmen. Armies could arm larger numbers of ordinary soldiers with firearms and gradually improve their effectiveness through discipline and coordinated tactics. Meanwhile, guns themselves kept evolving. Metalworking improved. Barrels became stronger and more consistent. Gunpowder formulas grew more reliable. Projectiles shifted from rough stones to carefully cast iron and lead balls that flew farther and struck harder. The real revolution wasn't a single invention. It was continuous improvement. Every battlefield exposed weaknesses. Every weakness inspired another innovation. And before long, firearms weren't just threatening individual soldiers. They were beginning to destroy something that had dominated warfare for centuries: castles. Stone walls that had once seemed nearly indestructible suddenly faced an enemy that never grew tired, never climbed ladders, and never stopped pounding. For hundreds of years, castles represented the ultimate military advantage. Their thick stone walls were designed to withstand arrows, swords, battering rams, and even early siege engines. An attacking army could spend weeks or months trying to starve defenders into surrender, because breaking through those walls was often impossible. Gunpowder changed that equation forever. The earliest cannons were slow, inaccurate, and cumbersome. But they possessed one quality no previous weapon had. They delivered repeated explosive force against the same section of a wall. A single shot might do little damage. 100 shots were another matter entirely. One of the clearest demonstrations came in 1453 during the siege of Constantinople. Sultan Mehmed II employed enormous bombards capable of firing massive stone cannonballs at the city's legendary Theodosian walls. Those fortifications had protected Constantinople for nearly 1,000 years, surviving countless invasions. Yet after weeks of relentless bombardment, sections of the walls finally gave way, allowing Ottoman forces to enter the city. The fall of Constantinople shocked Europe. If defenses considered nearly invincible could be breached by gunpowder artillery, then every kingdom faced the same terrifying reality. Military architecture changed almost overnight. Tall medieval castles gradually gave way to lower, thicker, angled fortifications specifically designed to absorb cannon fire. The weapons had evolved, and the world was forced to evolve with them. Cannons transformed battlefields. The next challenge was transforming the individual soldier. Early handheld firearms required lighting the powder with a burning fuse held by hand. That meant one hand often controlled the weapon, while the other managed the ignition. Shooting accurately under those conditions was difficult, especially in rain or strong wind. Then came one of the most important mechanical breakthroughs in firearms history: the matchlock. Instead of bringing a burning match to the powder by hand, inventors created a simple trigger mechanism that lowered a slow-burning cord into a small priming pan. Pull the trigger, the match descended, the priming powder ignited, and the main charge fired a fraction of a second later. For the first time, both hands could remain on the firearm while aiming. It seems like a small improvement today, but on a 16th century battlefield, it was revolutionary. Soldiers could fire more consistently, maintain formation more effectively, and coordinate volleys with greater precision. Entire military doctrines began changing around this seemingly simple mechanism. Yet the matchlock had obvious weaknesses. The glowing match revealed a soldier's position at night. Heavy rain could extinguish it. Strong winds created constant frustration. Keeping hundreds of burning cords lit during long campaigns required continuous attention. Inventors refused to stop there. Wheel locks appeared in the early 16th century, using spinning steel against pyrite to create sparks without a constantly burning match. They were mechanically brilliant but expensive and complicated. Later, the flintlock simplified the process by striking flint against hardened steel, producing reliable sparks with fewer moving parts. By the 17th century, flintlocks had become the dominant firearm across much of Europe because they balanced reliability, cost, and practicality better than earlier designs. The gun was no longer an experimental curiosity. It had become a machine that engineers continually refined, each generation solving problems the previous one had accepted as unavoidable. And the next leap would be even more dramatic, because firearms were about to become faster, deadlier, and powerful enough to reshape the balance of power across the entire world. By the 18th century, firearms had become the backbone of most professional armies, but they still suffered from one major weakness. After every shot, the weapon had to be reloaded from the muzzle. A trained soldier poured gunpowder down the barrel, inserted a lead ball, packed everything tightly with a ramrod, primed the firing pan, and prepared to shoot again. Even under ideal conditions, the process was slow. In battle, surrounded by smoke, fear, and chaos, it became even slower. Military commanders responded by changing tactics rather than waiting for perfect technology. Soldiers stood shoulder to shoulder in long lines. One rank fired while another reloaded. Then the next rank unleashed its volley. Instead of relying on individual accuracy, armies depended on discipline and coordinated fire. That system dominated battlefields for generations. Everything changed during the 19th century. Inventors introduced percussion caps, replacing exposed priming powder with compact metal caps containing impact-sensitive chemicals. The new system was far more dependable in wet weather and dramatically reduced misfires. Soon afterward came rifled barrels, carved with spiral grooves that spun the bullet as it traveled. That single improvement transformed accuracy. A projectile no longer tumbled unpredictably through the air. It flew with remarkable stability, reaching targets at distances earlier muskets could scarcely manage. Then came breech-loading firearms, allowing ammunition to be inserted from the rear instead of the muzzle. Reloading became dramatically faster, especially for soldiers lying behind cover. Within a few decades, firearms had advanced more than they had during the previous several centuries combined. The Industrial Revolution accelerated everything. Before factories, skilled craftsmen built most firearms individually. Small differences between parts meant repairs often required custom fitting by experienced gunsmiths. Mass production changed that completely. Manufacturers began producing interchangeable components with standardized dimensions. A broken hammer, trigger, or barrel no longer had to be handcrafted from scratch. It could simply be replaced with another identical part. Production became faster, cheaper, and more consistent. At the same time, metallic cartridges combined the bullet, gunpowder, and primer into a single self-contained unit. Soldiers no longer handled loose powder and separate projectiles under battlefield pressure. Loading became quicker, cleaner, and significantly more reliable. The repeating rifle followed soon after. Instead of firing a single shot before reloading, shooters could fire multiple rounds from a magazine. Lever action, bolt action, and later semi-automatic designs steadily increased the speed at which one person could deliver accurate fire. This wasn't merely an engineering success, it fundamentally changed global history. Industrialized nations could manufacture enormous quantities of standardized firearms, equipping armies on a scale unimaginable to earlier civilizations. Wars grew larger. Supply chains became more important than ever, and technological superiority increasingly determined victory. Yet through all these astonishing advances, one fact remained unchanged. Every modern firearm, from a hunting rifle to the most sophisticated military weapon, still depends on the same basic principle first discovered by accident over 1,000 years ago. A controlled explosion creates rapidly expanding gas, and that gas propels a projectile through a barrel. The chemistry that began in an alchemist's workshop was still driving the technology. But the final chapter isn't about mechanics. It's about consequences, because the invention of the gun ultimately changed far more than warfare. It reshaped politics, exploration, industry, and the course of human civilization itself. So who really invented the gun? The honest answer is that no single person can claim the achievement. Chinese alchemists accidentally discovered gunpowder while searching for something entirely different. Military engineers transformed that explosive powder into fire lances. Craftsmen cast the first bronze hand cannons capable of launching projectiles. Mongol expansion carried the technology across Asia. Islamic scholars and engineers refined gunpowder formulas and weapon designs. European gunsmiths strengthened barrels, improved ignition systems, and steadily increased reliability. Later inventors developed percussion caps, rifling, metallic cartridges, repeating mechanisms, and countless other innovations. The gun was not born in a single workshop. It evolved across continents over nearly 1,000 years, shaped by thousands of anonymous craftsmen, soldiers, chemists, blacksmiths, and engineers. Each generation inherited an imperfect invention and left it slightly better than they found it. That makes the history of firearms different from many famous inventions. There was no lone genius having one miraculous breakthrough. Instead, progress came through centuries of experimentation, failure, adaptation, and relentless improvement. Few technologies demonstrate the power of cumulative human knowledge more clearly. The invention of the gun tells a deeper story than most people realize. It began with a search for eternal life and ended by changing the way civilizations fought, defended themselves, explored distant lands, and built political power. Firearms helped determine the outcomes of wars, accelerated the rise and fall of empires, influenced colonial expansion, and reshaped military strategy across every inhabited continent. They also drove advances in chemistry, metallurgy, precision machining, and industrial manufacturing that extended far beyond weapons themselves. At the same time, every improvement carried a paradox. Greater reliability meant greater efficiency. Greater accuracy meant greater responsibility. The same scientific curiosity that produced fireworks for celebration also produced tools capable of unprecedented destruction. History rarely separates invention from consequence. That's why the story of the gun isn't simply about violence. It's about how human ingenuity works. A discovery made for one purpose can evolve into something its creators never imagined. Tiny improvements, repeated across generations, can alter the course of civilization more profoundly than any single moment of inspiration. The next time you see a modern firearm, remember that you're looking at the latest chapter in a story that began over 1,000 years ago, with 3 ordinary ingredients sitting on an alchemist's table: sulfur, charcoal, saltpeter. The people who first mixed them were searching for immortality. They never found it. Instead, they created an invention that would outlive kingdoms, redraw maps, transform warfare, and leave its mark on nearly every chapter of human history ever written.